Hey guys, Tracy here, Midwest Knife Maker Supply, USAknifemaker.com. Today we're going to give you a quick walkthrough on how to assemble a slip joint trapper kit. This is a single blade trapper slip joint kit that we have. We also have a twin blade, a little bit larger, and clip point, spay point. We're not going to show this because we're going to walk you through this. This will apply. So whether you're working on the single or the double blade, stay tuned and we'll get you going on how to make a slip joint trapper. Thanks. Okay, let's take a look at what we have in the package here. What you're going to get is a little box just like this, made in China. That's what it is. These are 440C hardened heat-treated blades. Going to have a mirror polish. They're sharpened, so be careful when you're putting it together. We've had about 10 people here put them together. No one got cut. Should be good. So what you get is the liners, stainless. The holes are drilled and located. The bolsters are actually spot welded on. So you'll see the bolsters are already attached. The holes are drilled and located. The bolsters have already been polished up. And so you're going to have the blade pivot hole, the back spring hole, and the center spring hole. And you're going to have 3 bits of pins for those. 2 of them are nickel silver and 1 is stainless. Now you're going to tell the difference. The nickel silver have a yellow tint to them. Going to be quite a bit softer than the stainless one. The stainless one is for the blade. Remember, stainless, blade, bolster, blade, stainless. Don't get them mixed up. We did on a couple others when we were learning how to make these kits. So nickel silver in the center spring and back spring. Okay. These are jigged dyed bone. That's deep dyed all the way. Don't be afraid to drill into them, color them, shape them, sand them, whatever you want. Now, the easy thing about these kits is if you don't like that jigged bone, throw them away, put some 1/8 G10 on there. Real easy to do. Just lay that on your 1/8 G10, flip it over, scribe it, drill it, and you can have a G10 scale on there also. Come with the back spring. It's already mostly set. Now it's got this odd little tool that comes with it, and we'll show you what that's used for. A lot of guys will just use heat treat foil, which is 0.002 thick. This is gigantic thick. And we'll show you how to use that, but if you've got a piece of heat treat foil, that's just about always 0.002, 2/1000 thick. And that's what most slip joint guys will use when they're assembling that. Now these will take a 1/16 and a 3/32. 3/32 for the bolster, back, and center spring. 1/16 in the liners and to hold on the bone. And you're going to see 2 holes there to hold that are lined up for the bone scales. And that'll be 1/16. And you will need to drill these out. Now the deal with these is that when you peen them on, chances are, good chance, you're going to crack the bone. Okay? It happens. Yeah, we've had about a dozen people put these together for us with 0 skill, some with some assembly skill in the past. Just about all of them reported that it just worked better. Take a little bit of super glue, put that on there, and go from there. So what we're going to do is we'll glue these on, cure them. Then we're going to come back and run a drill bit through the holes because these holes don't line up perfectly. We want to push that bone right up flush to the bolster, as flush as you can get it. And it's not a perfect thing. These aren't $400 slippies. These are $25, $30 slippies. And training tool, you can use them for patterns, that kind of thing. You know, you're not going to get a $400 slippy out of this when you're done. You're going to have a nice project. And a lot of guys report getting this kit done in about 30 minutes to an hour. Some guys took a couple hours. The 2 blade might add 20 minutes. It's basically just stacking everything up. So the order of assembly is you're going to glue these scales on. super glue, let them cure. You're going to come back and drill out the holes because they're going to be off just slightly, enough to be aggravating, so you're going to clean out those holes on both of that. Now, it comes with tiny, tiny little rivets, and those are for riveting on and pounding into the liner from the back. You'll see they're countersunk, and you'll have to drill out that hole because there's a little burr in there sometimes that prevents them from getting through. So that's going to go in, and that's going to hold that bone in place, and you're going to tap, tap, tap real gently on that. And the main thing that you want to remember on this is you want to get this little part right there flush, deep down, flush with the liner. The tolerance is pretty tight on these in one way, that if you don't get that flush and it sticks out even a little bit, it's gonna bind into the blade. So as you open, it's gonna hit that or that, especially on the tang area, and you're gonna bump into that little thing, and it's just gonna be aggravating. So we'll show you that when we get into the process. So we're gonna glue it, we'll tap those on, we'll stack it up, we'll put the front pin in, we'll put the back pin in, that'll be on the spring, just like that. Spring will flop around, that's just normal. You put the blade on, like that. And then what you're going to do is you're going to put pressure on that spring. That hole won't line up. So you're going to use a vise, you're going to use a C-clamp, you're going to use vice grips, you're going to use strong pliers, you're going to use anything you can to squeeze that, to move that back spring in towards where the blade pocket is. Put that final pin in. Then you're going to peen them all around. Take a Dremel tool, rotary tool, file, piece of sandpaper, knock off the rough edges on that, and then head spin them if you want. This is one we used a head spinner on, and we just made that little tool ourselves. Pretty easy to do, but not required. And then some of these we ground off flush. You'll see that we actually ground that part off. You're not going to mushroom that over because you'll crack that bone. The goal is to not crack the bone, but if you do, the super glue should hold it in place. So let's go ahead and get started. This is gap filling super glue. The reason we're using gap filling is because that's not dead flat. Super thin wouldn't quite bond as effectively as this gap filling. Okay, I've got the scales super glued on without gluing them to my fingers. We ran a drill bit on the back and center hole for the spring to clean out the misalignment, slight misalignment on the bone. Actually, the bone started to come loose again from the scale. I had to put some more super glue in there and do that. Then we ran a 1/16 drill bit through the two holes there. Now what we're going to do is we're going to take these microscopic little guys and tap these on to hold the jig bone in place, and so those go on from the back side. And we'll kind of peen those over and tap these in. And what we're trying to do is actually expand the metal. As you're tapping down like this on this little guy right here, we're going to want to get it flush in as much as we can. Take our friend the 1, 2, 3. And I want that in that little countersink as much as possible. So I'm going to get that as flush as I can. And then I'm going to tap down, trying to not hammer the bone because I'll shatter it and crack it if I hit it real hard. But what I'm trying to do is swell. It's called upsetting when you're pounding on like that. I'm trying to expand that metal by compressing it and locking it into that hole right there. I'm not interested in locking on and expanding into the bone. That if I go too much and pound it down, I'm going to crack that bone. The bone's going to give. Whether it's today, tomorrow, or next week, you'll look at all kind of old folders, and you'll find where there's hairline fractures along the pins, and that's where there's pressure on that pin, and this bone will move with humidity, and it'll shrink and swell, that kind of thing, and eventually it'll crack because the metal isn't moving. This is a natural material. That bone is. It's going to move. It's going to crack. I don't want, if anything, that hole can be slightly oversized in the bone, but I do want that flush. And I do want that piece of metal expanded, locking in to that little bit of gap right there. So I want to peen it enough where it's locked in, it's flush, and I'll grind off any that sticks out. Flush, locked in, and it's going to hold that in place. So okay, I have peened in these small little rivets here to hold on the jig bone. Now, I didn't peen them all the way flush because that certainly will crack it out. What I'm going to do is use a rotary tool to grind off the excess, and I'll grind that flush. What I'm concerned with is, again, that we have expanded that metal by compressing it to lock into the bolster so it doesn't come out later on. And I want to make sure it's flush, and it's not there, and it's not there, not and not. It's pretty good. I mean, but I'm going to just take a piece of sandpaper. Now, I've also pressed onto each of those pins just to make sure they're in there and it's expanded and it's held that. So I just grabbed any old piece of sandpaper, put it on a flat surface, give it a few scrubs, totally gone. This nickel silver is really soft. These little guys are nickel silver also. They're soft, it's flush. Now if you want, you can polish the insides if you choose to do so. I won't be on this one, I'll leave that to you. But that's it, they're flush and they're locked in. Stainless in the blade. Blade on. So kind of the center spring isn't pinned yet because it doesn't align. We'll have to compress that down, put the blade under tension, and then it'll open. There's the 90 and pretty close to flush. And there's the closed and not closed to flush at all because of the back spring and the kick and so on. So that's where we're at. Now this wedge goes, it's got a little notch in it that goes next to the blade, between the liner and the blade, and it fits right over that pivot pin. And the idea behind this is as you peen and expand this and blend into the bolster, if you kept peening without that in there, you would peen the whole thing shut and it would just lock up on you. So what you do is you get started with this, kind of get it going, and then at the end you peel that out and finish it up that way. So we've got that. We're going to put this guy in there and we're going to peen and tighten up some of these. We'll just use this. I'm expanding it a little bit and I'm trying to pay attention to getting that pin centered as I'm doing this. And I'm going around on the corner. When you peen, you don't normally use the ball side. That's only for really tight spots. When you're peening a pin, you use the flat side. We polished this, probably needs another polish. And you're peening around at a 45-degree angle to try and move that metal, compress it, mushroom it, and get it to fit and expand around into that bolster. This keeps it loose. Now keep in mind, the more you're compressing, you're also compressing this. The idea is you want that pin to lock into the bolster, but not lock up the blade. By squeezing it too tight or expanding it into that blade so much that it won't move. So it's a happy medium. And so you can definitely overdo this, and you can fix it. You'll have to just work it a little bit more. So now I want to put that center spring in, and I'm going to open it up. Now again, you might use a C-clamp, a vice grip, whatever you have. This just happened to work. We did it in the shop here several times with a bunch of people, so this is what we're going to use today. And I'm putting certainly hard on everything, getting it lined up. Now I've got this last pin, and I'm checking the hole there for alignment, and I might get, nope, I'm going to have to, what I'll do is I'm going to step over to the grinder and just put just a slight point on there to help me tap that through. I'm good, just the slightest point on there, and I can see the holes are lined up as I'm looking through that way. Okay. So we got the pin, had to get it off the vise, we want to squeeze that together. All right, we get the pin through. You can see the sharp inside there. Mark from the vise. We'll clean that up on the buffer, the sander, and that's peened and started. So we actually kind of almost have. It's really rough right now, but at this point we have just about a working knife. Now what we're going to do is we're going to finish peening a little bit. We'll take the rotary tool, the Dremel, and we'll grind those flush, grind that, and we'll spin those, head spin those, grind that off and buff that, and we're done. Now the rest of this process would take about 10 minutes. We've talked a lot during this, sorry for that. And the whole process on this, once you get it up and running, got all your tools in place, I think half the time in a knife shop is finding your tools and getting that set up. 30 minutes. You can have one of these put together, get it set, and go from there. I just used the head spinner. Now this is a homemade tool. We'll probably get some made up and be able to sell you a production one. But basically, this is just 4/16 stainless pin that we had. Took a drill bit and drilled down the end as best we could. Got it centered. Put a little dome inside there, a little concave dome as best we could. Drilled all the way to the rim. Then we took again our rotary tool, Dremel, and a cutoff wheel in there and cut just a narrow slot, and it's almost gone in this particular one, but there's still enough to round over that soft nickel, silver, or brass, whichever you can use for your pins. And so in use, gets in your drill press, you put down quite a bit of pressure in that, and with the dome and the slot that's in there, the slot is actually your cutting edge, and press down and it spins it. Now there's something called a concave burr for a Dremel tool also that works pretty good. One of the guys on Knife Dogs was using that, and his came out great. This is a little handmade. I actually heated it up and quenched it in water. Just took a blowtorch to cherry red, dropped it in water just to give it a few extra points in hardness. There, probably don't need to do that. Kind of a disposable tool. They wear out pretty quick. So we've got those rounded over, and basically that's just this back pin and this center pin. The others, we just use a rotary tool and ground them off. Now we're going to step over to the buffer and get it all cleaned up. We'll buff this. We'll buff a little bit there. I can feel a burr here and there that I'm going to just use on the buffer and polish up some of the bone just a little bit, polish that up a little bit. And then when you get that part done, then you have to work the blade, and I just grab this so I don't cut myself. And take some oil, and it's just going to feel terrible. It's going to open rough, and you're going to feel grit and that kind of stuff. And I don't know that the oil on this particular case matters that much, but we'll just put some oil in there. And we'll work that back and forth quite a bit until everything kind of warms up inside there and the metal expands. And work, and this may 5, 10, 15, 20 minutes, that kind of thing. It depends on how you peened and how tight it is and how the feel is. And what you're doing is you're wearing away metal, and you're putting oil in there and washing that metal grit out. And as it heats up, that metal will expand and rub itself raw again and loosen up the tightness, the tolerance on the however it's pivoting. And when it cools off, you'll feel a big difference. So You may have to do this for a few minutes. You may have to do it for longer than a few minutes, but basically you're breaking it in that way. Lots of oil to wash out the grit. And getting it to walk and talk. You know, this is, again, not a $400 custom job. The walk is how it feels. That's the walk. And the talk is how it snaps in and out of place. And this is still too tight to get anything out of, but you'll see that that's what walk and talk is all about. You'll hear that phrase kicked around. That's the walk is how it feels when it's open and closed, and the talk is how it snaps into closed position or half or closed or open position. So we'll run this over the buffer and we'll show some pictures of it at the end. Well, Carl, what do you think? Pretty good? Slip joint trapper model, single blade. Do the double blade the same way. I've got a little bit of work to do to loosen this up, but there you go. Hey, thanks for your business. USA Knife Maker, Tracy here. Stop by knifedogs.com for networking, sharing information on knife making techniques and that. And we'll see you in the next one. Thanks.